So good morning everyone. So now we are going to explain about operating system. My name is Irfan Syed from Department of Computer Applications. Now first of all, so what is meant by operating system? An operating system is a software program that serves as the intermediary between computer hardware and software application. In a computer component, we have two components. One is software and another one is hardware. So OS, operating system, is going to be an intermediary between software application and hardware application. So it provides the interface or connection between these two applications. Whenever you are going to take any permission from the hardware to access the software, then we are going to discuss that which software need to be access the hardware. So this process is going to be accessed by the operating system here. So operating system is, it provides user friendly interface for interacting with the computer and manage system resource efficiently. So OS is going to be the user friendly case. So it's going to be interface for interacting with the software applications as well as hardware applications. The operating systems control the execution of programs, manage memory and handle input-output operation. Now, what is the operating system does is, so it's going to be the execution of our program. Whatever the program we have stored in our data or our secondary drive, that means if the programs are in C language or Java or Python, so the programs are need to be executed to get output. For those kind of execution, so the operating system is going to provide us executing the program, and we need to allocate memory to that particular program, and we need to allocate memory to that variable what we have declared in the program. So those kind of things are managed by operating system with manage memory and handle input-output operations. So how we are going to give input is, so we are going to give two ways of giving the input. Either we can give statically or we can give dynamically. So giving the inputs also, the operating system is going to be managed. If we give the input is statically, then the operating system is going to allocate memory directly in the main memory, and whenever we are storing our program in secondary memory, the secondary memory programs are going to be executed with the help of main memory. So when we are going to give input, then we are getting our output. Those managed things are going to be handled with the operating system here. So if you see the interface, so here we have software and hardware components. The hardware and software components are going to be the handle between operating system. So this operating system is going to interface between these software and hardware applications here. Now before we can explore the details of computer system of operation, we need to know something about system architecture. Before knowing to operating system, we need to know basic computer. So what are the hardware components and what are the software components and what is meant by memory and how many types of memory we have. So these are the basic things we need to know. So we begin discussing the functions of system starts up and what is input output and what is the storage that we are going to store our data in our memory. And we also describe the basic computer architecture. So we have an architecture for the computer. So that architecture we are going to explore here. So first, so these are the components of computer. So here we have in the hardware section, so we have CPU, central processing unit, then we have memory and input output devices. So these are hardware components. Extra hardware components are speakers and USB flash and keyboard, monitor and mouse. So these are hardware components. Now software components are operating system and application programs. So operating system is a software application that provides the intermediary between hardware application and software application, and remaining application program means, so for example if you wanted to run C program, to that one, so we have a software called C Free or Dev C++. To run our Java program, we have NetBeans. For the Python programming, we have IDLE platform. So these are the applications that we need to be available in our computer as the software applications. Who is the user here? So people are going to be the users, or machines or other computers. So other computers are going to be interact with each other with the help of in that perspective. So users are computer. So these are the hardware components. Monitor is used to display our input and outputs, and input how we are going to input is, so we will give keyboard and mouse. So these two are going to be our input devices. Through these two devices we are going to give the input to the program, or we are going to give instruction to the program. Then speakers are used to listen the sound of the system, and CPU is the brain component of the computer. So whatever the process that we are doing, so all the work is going to be under CPU here. Then USB flash drives, so pen drives, secondary storage. So we have RAM and ROM. For those we will use secondary drive as or USB. Now this is the basic architecture for the CPU. So first we will have input devices here. So we will pass input to the computer, and computer is going to do operation or process. The CPU is going to do some process on this input, and we are getting our output here. So what is the input here? What is the input device or keyboard? So generally, so we are going to give input to the computer with the help of keyboard, mouse, scanner, joystick. So where you are most of the time, so we will use these two components, keyboard and mouse. So these are the common things used in the real-time applications. And scanner, whenever we want to print something from the data from the computer, for that one, so we will use scanner. And joystick, so joystick is used to play the games. So these are the input devices. So these input devices are passed to the CPU, then CPU is going to do some process. So CPU having control unit and ALU. So in this one, so whatever the inputs that we have received from the devices, so those are processed in the CPU, and after doing the process, so we are going to store those into main memory. So in that main memory, we will store all the information. After storing the information in this main memory, so we will pass this information to our output devices. What is our output devices are? Monitor. So whenever we are giving input from the keyboard and mouse, so we need to get some output result. So those result will be stored in monitor, displayed in monitor. And printer. So whatever the scanning device we are using here, so we need to print that data. So with the help of printer, we are going to take the printout of the scanner. And speakers. So for example, if we are playing a game, so whenever we are playing a game or listening a music, so we need to listen the music. So that's why we are using the speakers and headphones. So speakers and headphones are similar kind of things. Speakers are outside louder, and headphones are we will use with the joystick here. So this is the general basic architecture. So input devices are going to be give input to the CPU. So we will pass input. Then this will do some process. Then we will get our output here. So this is general process of architecture. So we will show one example here. For example, if we have taken input as A equal to 10, B equal to 20, S equal to A plus B. So here we have declared two components, two variables, A equal to 10, B equal to 20, S equal to A plus B. Here, so we have allocated 10 value for A. So what will happen is, so we have passed this input to the CPU, then this CPU will do, so here memory, so for this one, so we will having a memory, so this is my main memory. So here I have declared A equal to 10, B equal to 20, S equal to A plus B, that means 10 plus 20 equal to 30. So this is our input device where we have provided three variables with the values. So what we have done is, so we have applied two values to this particular one, and we are giving arithmetic operation here, A plus B. So we are doing addition here, so that means this S value is 30. So process has done in this main memory. After doing this process, so we need to know what is the output of this particular program. So that's why we will write print S. So where this print is going to be executed here. So here the process will do all the things. So we will declare A equal to 10 in main memory, and B equal to 20 in main memory, and S equal to 10 plus 20 equal to 30. So we need to print this data to get user information. So we will print this one as 30. So this 30 will be displayed in monitor. So after giving the input from the keyboard and mouse, so we will do process in the CPU. After doing this process, so the CPU is going to generate some output. That output need to be shown in monitor side. So this is how the working principle of a basic architecture. Now we have three types of operating systems. One is Windows, so this Windows, and another one is MacOS, and another one is Linux. So Windows are developed by Microsoft. So Microsoft are the company who are developed the Windows. So mostly in the world we are using the Windows. So those who are using Apple computers, they will use MacOS as their OS, and Linux is open source operating system. So whoever wanted to use the Linux, they can install the Linux and they will go through the Linux commands. So generally, so we are using the Windows in companies or in any other organization. Mostly we are using the Windows operating systems. So Windows operating systems are for computer and laptops, and MacOS are exclusive for Apple computers. Those who are using the Apple, so they will use MacOS. And for the Linux, it is a open source operating systems. So in this one, so it is highly customizable and used in servers. So where we are using the Linux is, so we'll use Linux in servers, embedded systems and mobile devices. So these are the three types of operating systems. Now let's see what is the functionalities in operating system. So first one is process management, next memory management, security, file management, error detection. We will see one by one. So first one is process management. So process management allocate process to task and process. So what is the process management is? So we will give process to CPU, so that process need to be executed. That process need to be executed. So that whatever the happening the things is going to be managed with this process management. So it determine which process gets to use the CPU at a given time, for how long, and ensure fair access to the CPU. So here let example we have P1, P2 and P3. So we have three processor P1, P2, P3. So this is my CPU, assume that. So this is our CPU. So what process management is doing is, so process management is going to allocate first P1 enters into CPU. So after completing the entire program of P1, so P1 is entering into CPU, then P2, P3 are in the queue state. So the P2, P3 are in the queue state. So whenever this process P1 has completed its process, then it will leave the CPU, then P2 enters into the process management CPU, then P3 is in the queue. After completing the execution of P2, P3 going to access the CPU and P3 will complete its time. So in this one, so we have time complexity here. For example, P1 need to complete its process in 10 minutes. Assume that P1 completion of program is 10 minutes and P2 completion program is 5 minutes, P3 completion program is 2 minutes. So in this case, what happens is, the process management is going to check who is the priority. So who is the first priority of the execution of the program here. So here when we are sharing this P1, so P1 need to take 10 minutes in the CPU, P2 needs to take 5 minutes in the CPU, P3 need to take 2 minutes in the CPU. So the process management is going to take, so which is the process is going to be complete in quickly. So here P3 is 2 minutes of execution time. So first what happens is, so based on the priority, so we will have P3, P2 and P1. So this is the based on priority. So this is based on execution time. So based on the execution time, so we are going to give priority to the CPU. So first we will give P3 as P3 to CPU. So we will give CPU to P3. Then this P3 is going to process its entire execution and it will complete in 2 minutes. After completing this P3 access, then we are allocating P2 to CPU, then CPU burst time is 5. So the process completion time is 5 minutes, the P2 is going to be complete its time here. Then P1, so P1 is going to have 10 minutes of time, so the completion time is 10 minutes, then later P1 has to occupy the CPU after completing the P2, then we are getting P1 execution time. So this entire management is going to be take care of process management. So CPU at a given time for how long and in fair access. So what is the time complexity of that particular program is need to be completion, so that take care by process management. And memory management. So memory management is allocate and manage primary memory between running programs. It keeps track of which part of memories are used by which program and swaps data between RAM and secondary storage. So here what happened is, so we have two programs A and B. So we have two programs here. So in these two programs we need to allocate memory here. So we are saving this in secondary memory. So we are storing this A and B program in secondary memory. So we need to execute this memory. So how we are going to execute this memory is, when we are executing the one program, the program is going into main memory. From the main memory we will execute the program and we will get our result there. So here, so what happens, so it allocate manage primary memory, first memory, main memory is going to be running the program here. So it keeps swap data between RAM and secondary memory. So what it happens is, whenever we are executing our program from one secondary memory to main memory, so it will swap data between RAM and secondary storage. So from that one, so we need to take the programs from secondary memory to main memory to execute the program here. Next, file management. File management keeps track of where files are stored on secondary storage. So we are going to store our all files in secondary storage. Then from the main memory, so the file manager what it will do is, so it will going to provide us, so whenever we are opening a new file or create a new file or opening a file or reading a file or closing a file or writing anything on file. So what are the file operations that we need to perform? So all will be taken care and handled by file management. Next one is security protects the computer system from unauthorized access. Those who are not authorized, for example, my computer having authorized as the password as me, and I have given one password to my computer. If someone wanted to access my data without knowing my information, so that called as the unauthorized accession. So those kind of things will be destruction due to our data. For those one, so we will use security protects here. Next, error detection. So operating system is going to detect our errors. It may be either software failures or software bugs or hardware failures or data errors. For example, we have given one program, C language program. In the C language, we have missed something semicolon or double quotes. In that one, so what it will happen is, so the operating system has run the program from the main memory. After running that program, so it will show us, so this is the bug we have detected and this is the error that we have detected from this particular program. For example, if we will take a C program, hash include stdio.h, and we have int main, so this is a simple program that we have written. So hash include stdio.h, so these are the header files, and int main, so we are returning int, then a equal to 10, I have written a equal to 10 without closing the semicolon here. So what it happens is, so when we are running this program, I have saved this program as s.c, assume that, so s.c, so c means C extension file. So this program has having the C language. So after executing this program, what I will get is, so operating system will run this program in main memory. After running this main memory, so we will get one error, so semicolon missing. So what is semicolon missing is, in C language program, we need to mention after declaring variable and with its value, so we need to mention the semicolon to disclose that one. So here, first the program starts from main function. After from main function, so we will move into variable declaration part. Here the variable declaration, so we have a main memory. In the main memory, we are going to have a memory management. So the memory management going to give one variable, one particular memory to a variable, then we will store our data. So this is memory. In this memory, we are going to store our a value. After storing our a value, so we will return that one. So once we have given the input a equal to 10, and when we are running the program, so after running the program, so we have, if we have any error, then error will be displayed in this side. After rectifying this error, we need to get our data. So here print 10, print a, so that means, print a percentage d ampersand a. So this is when we are printing this data, so we will get our output in the monitor. So how we are giving this input a equal to 10 is, so through keyboard we are giving a equal to 10. So after giving the input from the keyboard, so we will execute this program in, and whenever we are executing that one, so it will be in main memory. So main memory is going to allocate some memory to our variable. From the variable, whatever the memory allocation has done in the memory allocation, with that one, so we will run this program. If any error has detected, then error detection is going to be throw some errors. So these are the errors that we need to rectify to run this program. After rectifying this program, so we will get our output in the monitor screen. So this is how the process is going to be work with the program here. First one is process. So this one. So first one is process management. In this process management, the program is one process that need to utilize the CPU. Then memory management. After process execution, so once this process has executed into main memory, so we need to allocate some memory to the particular thing. So a equal to 10. So we have mentioned a equal to 10. So the memory is going to be allocate a equal to 10 here. Then file management. So what is the file management is, this file has stored in secondary memory, that means in pen drive. So we need to get this main secondary memory to main memory. That means swapping the data from secondary memory to main memory. After completing the execution, we will swap the main memory to secondary memory. Then security protection. So security protection for this program is, so if anyone has opened this program, so we will get to know who has accessed that particular program. Then error detection. So error detection means when we are executing this program, if any kind of bugs or any kind of issues we have happened, so the error detection is going to be throw some errors to us. So this is the mistake that we have done, and this is the error that we have found. First rectify this one. So after rectifying this all the things, so we will get our execution part, then it will display our output to screen monitor. So these are the functionalities that we are following for operating system. Now what is the importance of operating system? So first one is resource management. So the OS efficiently allocate resource like memory, CPU and storage to programs. This prevents program from fighting over resource and keep things running smoothly. That means, for example, if we have 3 processors, P2 and P3, so these are the 3 processors we have. So these are the 3 processors need to be executed in the CPU. So at a time 3 processor cannot be accessed the CPU. So the resource management what it will do is, so it will do, so first it will allocate memory to all the processor. So in main memory, so it will allocate P1, P2, P3. So based on the scheduling algorithms, so we will give process to the CPU. So the resource management is going to be take care of the process execution. So instead of running all the components at a time, all the process at a time, so we will give priority to one processor. So here we will apply scheduling algorithms, which process need to be executed in the first, and if it is first come first serve or shortest path or priority based or round robin. So these are the 4 scheduling algorithms we have. Based on the scheduling algorithm, so we will give one process to CPU. So this is the resource management. That's how allocation is doing for the process to do the CPU programming. Security. The OS act as a gatekeeper, protecting your system from unauthorized access, viruses and malwares. So the OS operating system, so it will provide the security. So in the what it will provide as the security is, so unauthorized people who are not accessed for the particular thing, so they cannot access our data, and it will provide from some virus and malwares. So it enforces things like password and file permission need to be kept data secretly. So we have to mention one password, and we will give some protection to the files also. So these are managed by security. Then usability. The OS provides a user interface like a desktop or touch screen that lets you interact with the computer. Without an OS, you need to be a computer program to use it. So here the usability means the OS is providing interface like computer or touch screen. So if we have touch screen, then we can perform operation with the hand gestures, then it will interact with the computer. Without OS, so we are not going to be take care the computer program to use it. Then hardware abstraction. The OS act as the translator between the software used and the physical hardware. This lets program run on different computers without needing to be rewriting for each specific type of hardware. So that means the OS is going to be act as the translator between software applications and hardware application. So software application means in C language we have written in our English language. So the OS is going to be the convert the application language into binary forms, zeros and ones. Then these are going to be handled by hardware things. Then we will get our data here, output here. Then standardization. The OS provides a standard platform for running software. So OS, if our OS is standardization, then our software will be run smoothly. So this allows developers to create programs that will work on any computer with that OS. For example, if I have written a programming language, so that need to be supported in all other OSs also. So those kind of things, so we will use the OS is going to provide a standard platform for that one. For example, I have written the programming in Windows 7. So I need to run that program in Windows 10. So obviously the OS is same OS Windows. What we have done is, so we have changed the version from 7 to 10, but the platform is standardization. So when the program has run in the Windows 7, that means the program will be executed in the Windows 10 also. That why it was running is, so the OS is standard platform for the Windows. Operating system structure. So the operating system structures refers to the way in which various components of an operating systems are organized and interconnected. So structure means, so we have four categories here: simple structure, layered approach, microkernel, hybrid system. So these are the four structures, four operating system structures that we are going to discuss. The first one is simple structure. So the simple structure of an operating system so do not have well defined structure. So it is the basic and old version of first structure. So these systems will be simple, small and limited systems. So in the previously, so we have, this is the first operating systems, that is MS-DOS. So in this structure, so it is simple and it will be having a limited systems. So when we are going for the large cases, so this application is not going to be work for us. So in MS-DOS, the interface and level of functionalities are not well separated. So this is the basic structure. So in the starting stage, they have developed this structure. So in this structure, the level of functionalities and data is not separated. So all files will be in single folder. In MS-DOS, application program can access the basic I/O input routines. This causes the entire system to be crashed when the user program fail. For example, here we are giving the input outputs. So we are giving the input to the computer and the computer is going to process something and it will give the output to us. For example, if we have given wrong information or it is a miscalculation, then it will cache the output to us. If the power failures, then it will it will crash the system failures. Program fails, that one. So this is the general application. So this is the OS structure. First we have application program, then resident system program, MS-DOS device drivers, ROM based device browser. Here in the application program, so we will write our program. What is the program that we are going to be executed? Then residential program. So the program what we have written, so it will be enter into the CPU side. After CPU, so MS-DOS is going to be take the driver's help to execute that program. So here the programs are going to be executed with the help of drivers. So this is the general structure of simple, OS structure, first OS MS-DOS structure. Now layered approach. So the operating system is broken into number of layers, levels. We are calling these separation layers as levels. The bottom layer is layer 0 is the hardware, the highest layer is the user interface. So in this side, so this is the hardware, that is layer 0, and when we are going on the top side, so this N, so what is the last layer we have? That is the user interface. In between, so we will having layers, layer 1, 2, 3 and so on. So this entire OS structure is divided into layer categories. The main advantages of this layered approach is simplicity of construction and debugging. The layers are selected so that each is a function and service of only lower level layers. So here the lower level layer will take input from the layer 1 and it will do some process, then it will give to layer 1. The layer 1 take data from the layer 2, then it will be giving data to layer 2. Likewise, layer by layer approach, we are doing the things here. The major difficulty with the layer approach is involve appropriately defining the various layers, because a layer can use only lower level layers. For example, if layer 1 wanted to use the layer 2 data, so it is not impactful, because the layer 1 is only accessing the lower level layer here. A problem with layered implement is that they tend to be less efficient than other types. So when we compare to the remaining things, for example, previous simple DOS, so when compared to the previous one, it is better. When compared to the next terms, so it will be very difficult. Operating system structure as microkernels. So microkernels, this method structures that operating system by removing all non-essential data components from the kernel and implementing them as system and user level programs. So what will happen is, so this is our microkernel operating system structure. So we have a hardware and basic interpreting IPC here and virtual memory scheduling, and this is the application. In this application we will be having application IPC, what is the device drivers, and what is the server, and what is the file server we have. So in this one, so in the application, whatever the non-essential things, so whatever the non-essential thing will be available in, so it will going to remove all the things here and it will remove all the non-essential components from the kernel and implementing them as the system and user level program. So here the non-essential things will be removed and this will be going to our application here. After application, so we will divide it into what is the application IPC and what are the drivers that we are going to use and what is the Unix, what is the server and what is the file that we are using as the server. After this, so we will go for the basic IPC and virtual memory. So memory allocation will be having here scheduling, then we will interact with the hardware components. So microkernels provides minimal process and memory management in addition to a communication of facility. So this is the memory that they are going to be provided to access our data here. So the main functions of the microkernel is to provide communication between the client program and the various services that are also running in user space. So these are the various running spaces. So application, devices, Unix and file server, and so these are the various services that are running in the user space, and the main function of the main microkernel is to provide communication between the client program and the various one. So this is client program and this is our components. So what is the microkernel work is? So it need to provide the interface between application, that means client server and hardware components. So this is the general structure of microkernel operating system. So it's going to give a connection between, a communication between the client server and various devices in the running space. The client program and service never interact directly, rather they communicate indirectly by exchanging message with the microkernels. So here what will happen is, so for example, A is my client server and B is my server. A is my client and B is my server. So here, so these A and B are not directly communicated. So there is no chance that the client is directly accessing the or directly communicating the server. So there is no possibility of directly accessing. Indirectly they will access through microkernel. So this is the point. The program, the client program and the service never interact directly. Rather they communicate indirectly by exchanging the message within the microkernel. So here we will having a client server message as hello, and this is our server. The server is empty now. So the first the client need to give some client data to server. So the client cannot communicate directly to the server. Instead of directly communicated with the server, so we will be having our kernel, microkernel. So this message will be passed into kernel first. So hello will be coming into the kernel, microkernel. This microkernel is going to give this kernel to server. So here, so communicate indirectly by exchanging the message microkernel. First, so we have a client. So the client has some message to pass the server. So client and server cannot directly access or communicate. For that one, so what we are doing is, so we are going for the microkernel to pass our information from the client to the microkernel. So this microkernel is going to pass that information to server. If server need to send any message to the client, so this one has to pass message to this one, and this will return this message to hello. So this microkernel is going to be the act as the intermediary between client server and server. Next one is hybrid system. So the word hybrid means the combination of 2 or 3 components here. So the operating system combines different structures, resulting in hybrid systems that address performance, security and usability issue. So what is the hybrid structure means? So the operating system is going to be combine different structure. For example, if we combine layered structure with microkernel, so what it will happen? The microkernels, the layered structure. So what layered structure happens is, the layered structure, so we will be dividing all layers into from layer 0 to level n. So level 0 indicates the hardware and level n is going to be declared as the software. So for this one, so if we combine with it with microkernel, so what it will happen? So the microkernels are going to be act indirectly between client and server. If we combine these two, so that means a hybrid structure will be formed. So they are monolithic because having the operating systems in single address space provide very efficient performance. When we combine both different kind of operating structures, so we will be having efficiency more and reusability more. So this is one. So this is the hybrid structure. User mode, handle other OS features. So whatever the operating system that we have mentioned here, so process management, file server, input output management, memory management, and kernel mode. So this is from the microkernels. So handle only basic OS features. What is the device drivers and what is the low level address space, low level process management and inter-process communication, and then hybrid hardware. So here we have combined two things. So one is going to be handle other OS features. So whatever the features that OS is going to be provide, for example, how we are going to process the management, how we are managing the process, and file servers, where we are storing our files, and how we are going to open the file, how we are going to create the file, how we will read the file. So all will be here, file server and input output management, how the user is giving the input and how the OS need to be give the output. So those are things managed by the input output device management and memory management. When we are given one output on program to that particular OS, so it need to be allocate some memory to the particular one. So that one, so how we are going to allocate the memory, all will be handled by memory management. So this is one structure. After that, so kernel mode, what it will happen is, so device drivers. So what are the drivers that we are using? Kernel user mode, so it will be handled by device drivers. Then low level address space management. So this is the address space management which is going to be handled in the level sites. Then low level process management. So what are the process in the management, all will be handled here. And IPC, inter-process communication. So how the process are going to communicate with each other. So these are the things with the help of hybrid system. So using the hybrid system, we will be having the benefits of both structures. For example, if we take layered and microkernel, whatever the properties that we have, so it will be applicable for both. For example, in layered approach, we have we are facing some difficulties, but when it comes to microkernel, we are not facing these difficulties. So for these difficulties, we will rectifying with the microkernels. Whatever the issues that we are following in the microkernel, it will be rectified with the help of layered approaches. Okay, thank you.